Hello everyone, today I am presenting my video assignment on capital budgeting using cumulative present value CPV analysis. In this assignment, our task is to evaluate two competing investment opportunities, Project A and Project B. Both projects require an initial capital outlay of $50,000 at year zero. We are using the discount rate 10% to account for the time value of money. Over the next few minutes, I will walk you through the step-by-step Excel model I built to calculate the discounted cash flows, compute the cumulative present value for each year, visually compare the two projects using an Excel line chart, and finally conclude with a formal recommendation in which project adds more value to the firm. So let's examine our raw data set in Excel. In cell B1, we entered our discount rate of 10%. Column A represents the time horizon from year 0 to year 5. Column B shows the undiscounted cash flows for Project A. Year 0 is minus $50,000, followed by $10,000 in year 1, $15,000 in year 2, $20,000 in year 3, $25,000 in year 4, and finally $10,000 in year 5. Column C shows the undiscounted cash flows for Project B. Year 0 is minus $50,000, followed by $5,000 in year 1, $10,000 in year 2, $15,000 in year 3, $30,000 in year 4, and finally $20,000 in year 5. If we simply summed up the nominal cash flows, Project B would look higher. $80,000 total inflows versus $80,000 for Project A. However, the money received in the future is worth less today, therefore we must discount these cash flows. Now, let's move to requirement 1, discounting each year's cash flow to its present value. The standard mathematical formula for present value is present value equals to cash flow divided by quantity 1 plus r power t. In Excel, we implemented this formula in columns D and E. For project A in cell D4 over here, which is year 0, the value remains minus $50,000 because year 0 cash flows are not discounted. For year 1 in cell D5, over here, we entered B5 plus 1, the rate of B1 raised to the power A5. B5 is the year 1 cash flow, which is $10,000. And $B and $1 represents the absolute reference logged to our 10% discount rate. And A5 is the exponent representing year 1, right over here, as we can see. This gives us a discounted year 1 present value of $9,090.91 for project A. Like, as we can see over here, $9,090.91. We round this off to 91 cents. And we copied this formula down to year 5. $10,000 received in 5 years from now is worth $6,209.21 today. As we can see that I have used this formula throughout the entire column. We applied the exact same formula in column E for project B using C5 1 plus $B $1 raised to the power A5. For example, year 1's we applied the exact same formula in column E for project B using equals C5 divided by 1 plus $B $1 raised to the power A5. For example, year 1's present value for project B is $4,545.45. Next, let's cover requirement 2, computing the cumulative present value for each year. Cumulative present value tracks the running of total of discounted cash flows over time. It shows us the net recovery of our investment year by year. In cell F4, right over here, which is year 0, the initial cumulative present value for project A is minus $50,000. In cell F5, year 1, we use the cumulative formula equals F4 plus D5, as you can see over here. This adds year 1's present value, which is $9,090, to year zero's balance, bringing the net unrecovered amount to minus $40,909 and 9.9 cents. Dragging this formula down through the year 5 gives us the full trajectory. Year 2 is $28,512.40. We round this off to 40 cents. Year 3 cumulative present value is minus $13,000, or to be precise, minus $13,486.10. Year 4's cumulative present value is plus 3,589.24 cents. We round this off to 24. Notice that it turns positive over here after being negative for 3 consecutive years. Year 5's cumulative present value is $9,798.45. Again, we round this off to 45. We did the same for Project B in column G. Project B's Year 5 final cumulative present value reaches plus $6,988. As you can see that we have used the same formula over here and dragged it down to our Year 5, which makes our final cumulative present value is which makes it $6,988.47. Again, we round this off to 47 cents. More importantly, the final cumulative present value at year 5 represents the net present value or NPV of each project. Okay, moving on to requirement 3, comparing the graphs of the cumulative present values of both projects. We plotted the CPVs using a 2D line chart with markers where the x-axis represents year 0 to 5 and the y-axis represents the dollar value. Looking at the chart visual, number 1, the steeper or early recovery, the blue line, project A, climbs significantly faster during years 1, 2, and 3 compared to the orange line or project B. This is because project A generates heavier cash inflows early on. And number 2 is discounted payback period. Project A crosses the zero axis and breaks even during year 4, specifically at $3,589.24, which we saw over here. Project B remains negative through year 5, minus $5,429.96, which we can see over here, and only breaks even in year 5, as we can see over here in the table and also in the graphs, where we can see that it is in the minus value over here, but breaks even in year 5. Finally, requirement 4, recommending the better project. Based on our cumulative present value analysis, Project A is clearly better than Project B, and I recommend accepting Project A for 2 major financial reasons. Number 1 is higher net value creation. Project A delivers a total net present value of $9,798, and whereas Project B delivers $6,988.47. Accepting Project A adds $2,809.98 more value to the firm. And then there's number two, which is faster capital recovery. Project A recovers its initial $50,000 investment on a discounted basis in year four, whereas Project B requires 5 full years to break even. Achieving faster payback reduces liquidity risks and allows the firm to reinvest its cash sooner. In summary, Project A creates superior financial value and carries less duration risk. So that was the entirety of my analysis. Thank you so much for watching my analysis. It's been a pleasure, and thank you so much for your time and attention.